My dear students, in this class I am going to discuss critical phenomena. In the previous class we understood liquefaction of gases and Andrews isotherm of carbon dioxide. So before going to discuss critical phenomena, it is better if we know the application and merits of the van der Waals equation of real gases. So this van der Waals equation of real gases which holds good in all condition of temperature and pressure, and it successfully explains the isotherm of PV by RT versus PV for various gases, and from this equation we can calculate the critical constant like critical temperature, critical constant, and inverse temperature and Boyle's temperature using this equation. So now let us see its application. Critical phenomena. So critical phenomena is nothing but it is the smooth merging of gas into its liquid at various thermodynamic parameter like temperature, pressure, and volume. So this is called as critical phenomena. So there are three critical phenomena. One is critical temperature and critical pressure and critical volume. So critical temperature is nothing but you just look at this graph. So just now we discussed Andrews absorption isotherm. In the graph we can observe that here one point is there. So this is the graph. So in this point what happened? So here this is the region in which there is an equilibrium between gas and liquid, and this is completely a liquid and this is completely a gas. At this point what happened? Above which liquefaction do not takes place even at high pressure. So at this point the temperature at this point, so this is called as critical temperature. It is the temperature so above which we cannot liquefy the gas even if we are applying pressure. So that minimum temperature is called as critical temperature. It is indicated as Tc. Tc is equal to 8A divided by 27 into R into B, where so A and B are van der Waals constant and R is a gas constant. And critical pressure is it's the minimum amount of pressure required to cause liquefaction at temperature. For example, at this temperature, for example, if you take carbon dioxide gas, so the critical temperature is 31 degrees Celsius. 31 degrees Celsius, and the corresponding pressure at this temperature, the corresponding pressure is 73 atmosphere. So this 73 atmosphere is called as critical pressure. That is the pressure of that gas or of that liquid at critical temperature. It is called as critical pressure. So it is equal to Pc is equal to A divided by 27 B square. Then critical volume. Critical volume is nothing but the volume occupied at critical temperature and pressure. So it is called as critical volume. So usually the critical volume of a carbon dioxide is around 75 meter cube per kg. That is 1 kg of gas can occupy more than 70 liters under this critical temperature, under the temperature of 31 degree and 73 atmospheric pressure. So this is called as critical constants. So now let us derive this critical constant by using van der Waals equations. So we know that this is the van der Waals equation, that is P plus A divided by V square into V minus B is equal to R. So this is the van der Waals. Actually this is nRT. So is equal to nRT is equal to nRT. This is called as van der Waals equation. Then if you multiply this term with this, so PV, so P into V, PV plus PB and plus AB minus AB. This is the equation we are going to get. So if you multiply these two terms, dear students, So you please goes on doing with me. This derivation involves a simple mathematical expression. So actually this is a van der Waals equation, but for 1 mole of gas that n is equal to 1, that's why it become RT. Before it is nRT, now it is just RT, that is gas constant and temperature. Then if you multiply these two terms, we are going to get equation number 1, that is PV plus A divided by V minus PB minus AB by V square. Then if you multiply equation 1 with V square, so then multiply all the term with V square, so we are going to get, already V is there, so it become PV cube, and A by V into V square is equal to AV minus PB V square minus AB V square into V square is equal to AB is equal to RT V square. So then, so take RTV into LHS, then it becomes PV cube plus AV minus PB V square minus AB minus RT V square is equal to 0. So consider this is equation number 2. So this is equation number 2. Then, so divide the equation number 2 by P. If we divide by P, we are going to get V cube plus AV by P minus BV square minus AB by P minus RT V square divided by P. So this is the equation we obtained. Then in this equation, some common terms are there. So BV square and RT V square by P. So V square common is there. And so we can simplify this. If you further simplify this equation, you are going to get equation 3, that is V cube is equal to, so we took V square outside, then B plus RT by P is remain, plus AV by P minus AB by P is equal to 0. And dear student, this equation is like a cubic equation, and the cubic equation has 3 solutions. Then at critical temperature, so at critical condition, what happened? The temperature is equal to Tc, that is it become critical temperature, and P, pressure of a gas is equal to critical pressure, and volume of a gas is equal to Vc, because we are deriving an equation for critical constant. That's why, so we have to apply van der Waals equation at critical temperature, pressure and volume at critical point. So at critical point, T is equal to Tc, that is as I said in case of isotherm of carbon dioxide, it is equal to 31 degree, and Pc, and volume of a gas is nothing but so critical volume. Then if you rearrange this equation, V is equal to Vc can be written as V minus Vc is equal to 0. Then we can also write as V minus Vc whole cube is equal to 0. Then if you expand this by applying A minus B whole cube equations, so we are going to get V cube minus 3Vc V square plus 3Vc square V minus Vc cube is equal to 0, that is A cube minus B cube plus 3A square 3 minus 3AB square plus 3 A square B. So this is the equation we obtained if we apply the arithmetical formula to this equation. Then if you compare the equation 3 and 4, because at critical condition equation 3 and 4 becomes equal, and equation 3, then compare the coefficients of equation 3 and 4. So if you compare the coefficients of V cube, so the coefficient is 1 in both the equation, but in this case what happened, V square, the coefficients of V square here is B plus RT plus B, but here so 3Vc is the coefficient of V square, and the coefficient of V in the equation 3 is A divided by P, and in the case of 4 is 3Vc square is the coefficient, and in case of these, so these are all the constant, AB by P is equal to Vc square. Then on equating the equation number coefficients of equation number 3 and 4, why? Because so these equations must be equal under critical point. So then if you equate equation 3, the coefficient of equation 3, so we get 3Vc. So 3Vc, that is 3Vc is nothing but Once again, you just look at here. So 3Vc, as I said, so we are equating coefficients of V cube, V square, V and constant, and we have got, so 3Vc is equal to B plus RT by PC. This is equation number 5. Then if you equate the coefficients of V volume, then the coefficients of volume is 3V square is equal to A by PC. So you keep those two equations, then only you can understand this. So consider this equation as 6 and equate the constants. So VC square, VC cube is equal to AB by PC. So take this equation number 7. Then divide equation 7 by 5. Dear student, you do this simple mathematical operation in your book. If you divide equation 7 divided by 6, and if you simplify, you are going to get VC is equal to 3B, that is critical volume is equal to 3 into B. You simplify it later, and if you, so then substitute the value of VC in the equation 6. So we know that 3 into VC square. So VC, we know the value of VC, that is 3B. So if you square this, it becomes 9B square. So 9B square is equal to what? Is equal to A divided by PC. Then take PC outside, and if you simplify this term, so 3 into 9 3s are 27. So it becomes 27B square. Then if you take PC here, it becomes A divided by 27B square. So this is the equation for, so critical pressure at critical temperature. So now we have got the expression for critical volume and critical pressure. Then substitute the value of PC and VC. We have got the value of PC and VC. So in the equation 5, so you are going to get TC. It's very simple. So 3 into, so what is the value of VC? So is equal to 3B and is equal to, so B you don't know, B value, and RT by what is the value of PC? So PC is equal to A into A divided by 27 by 27B square. It will go to numerator. Then further, if you simplify this equation, so you are going to get TC, critical temperature, is equal to 8A divided by 27 RB. So dear student, this is how we can derive the equations, the mathematical equations, which is going to give the relationship between van der Waals constant and critical constants. So this is the one of the applications of van der Waals equation of real gases. This derivation is very simple. So first take, once again I'll explain. First take van der Waals equation, and you multiply the LHS term, you will get equation number 1, and you multiply the equation 1 by V square. Then if you rearrange the equation, you will get equation 2. Then you divide the equation by P. Then if you divide and after rearrange, you will get this equation. Then again, if you rearrange this equation, you will get 3. Then at this point is very important. At critical point, the temperature become critical temperature, pressure become critical pressure, volume become critical volume. Then we can write this equation as V is equal to VC, has V minus VC is equal to 0. Then V minus VC whole cube is also becomes 0. Then if you expand, you will get 4. Then you must equate the stoichiometric coefficients or the coefficients of these cubic equation. So you are going to get equation 5, 6 and 7. Then you divide equation 7 by 6. So you will get the value of VC, critical volume, and if you substitute the value of VC in the equation 6, you will get critical pressure, and if you substitute the value of both VC and PC, and you will get the equation for critical temperature. So this is how we can derive the equation of critical constant by using van der Waals equation.